Hey folks, today we're going to continue our discussion of air pollution. This is sort of a two-part video. The first part being about non-anthropogenic pollutants. That'll be pretty brief. And the second part we'll get into indoor air pollution. So non-anthropogenic pollutants are air pollutants that are formed by things that aren't human, including things like carbon dioxide, sulfur dioxide, and particulate matter. Carbon dioxide is an air pollutant in that it alters the climate. And we know that there are a lot of non-human sources of CO2. There's a lot of exchange happening between the ocean. There's obviously a lot of exchange going on between cellular respiration in animals and plants, as well as the absorption of CO2 through photosynthesis. We also see a lot of respiration happening in the soil. There are a lot of microbes and insects and all sorts of other biotic organisms that live inside the soil and are doing respiration. Not to mention decomposition, which also produces CO2, so there's a lot of carbon dioxide being released there. And there's also some being released from volcanic eruptions, although they're so infrequent that it's a very small percentage. But volcanic eruptions do release sulfur dioxide, a pollutant that can irritate the lungs and lead to acid rain. Additionally, there are lots of sources of particulate matter in nature. Sea salt is a great example, as well as dust, which is just airborne soil, which is a pretty cool way to think about it, I think. Secondary sulfate, like I said, coming from volcanoes, but also things like pollen, black carbon and soot, ash from wildfires, and sand, as well as volcanic ash. So there are lots of sources of air pollution that are non-anthropogenic. So although a lot of it comes from human activity, not all of it does, and I'd like you to keep that in mind. Okay, that was very brief. Now we're going to transition into part two, which is the bulk of this presentation, which is about indoor air pollutions. What are they, where they come from, and how they can harm us? I'm not going to explain this joke. You either get it or you don't. If you get it, great, you're wonderful. If you don't get it, you need to educate yourself. Okay, so indoor air pollutants are exactly what they sound like, but they're a little bit different because than sort of outdoor air pollutants, because you're in an enclosed space, right? And you need ventilation in that space. Otherwise, an enclosed space can very quickly become dangerous compared to an outdoor space. Some of the examples of anthropogenic indoor air pollutants, this is the abbreviation I use, that we'll talk about include combustion and its products, lead, volatile organic compounds, and asbestos. Let's start with combustion. So combustion, we know, produces carbon dioxide, but it can produce carbon monoxide as well. We have talked about how that is extremely dangerous to breathe. And in enclosed spaces like this, a small amount of carbon monoxide can build up very quickly, whereas outdoors it's not as much a threat. Nitrous oxides can also be released from combustion and can lead to pneumonia and asthma, sulfur dioxide, which can lead to bronchitis, emphysema, and asthma, and particulate matter, which can do a lot of damage. Asthma, COPD, emphysema, bronchitis, lung cancer. This is chronic obstructive pulmonary disorder, by the way, and tobacco smoke as well. All of these things, when burned indoors, can build up to really high concentrations and do a lot of damage. And if you're smoking indoors, that's one thing. But in many developing countries, they rely on biomass for fuel to cook their food and heat their homes, and so all of that pollution is now indoors, and that's an added threat that you don't get with electric heat or an electric stove. We've talked about this before, but carbon monoxide is when fossil fuels are burned improperly. It's an asphyxiant, meaning it inhibits your body's ability to absorb and deliver oxygen to different parts of the body, and it's extremely poisonous. And in developing countries, it is a bigger threat, especially if the homes that they're living in don't have good ventilation. Can result from the burning of all sorts of different things for fuel. And unfortunately, it means that people with the least resources are going to suffer the greatest risk, because not only are they burning stuff indoors, but they also don't have as good access to health care. And we can see, if we look at this map, indoor air pollution causes much more deaths in developing regions of the world as opposed to developed nations. The redder an area it is, the more deaths there are from indoor smoke. But additionally, you can also see that generally speaking, the trend is downwards. If we look over the past 30 years or so, deaths by indoor air pollution have dropped substantially in North America, Western Europe, Oceania, North Africa and the Middle East, Central Europe, all of these colors on the top here. But these light blue colors and the darker blue colors, Sub-Saharan Africa and South Asia, the drop is less steep. So hopefully we can see that continue to drop as they get more access to safer and better fuel sources. So how can we address these combustion pollutants indoors? We need to ventilate with chimneys, windows, and vents. We can have kitchen equipment that burns cleaner or switching to a different energy source. Obviously, that's not going to be easy for everybody, but it's something we can try to do. And we can also cook outdoors. I mean, look at this guy. He's having the time of his life, barbecuing up a grill for everybody in. He kind of looks like he's photoshopped in, but he is cooking outdoors, and that's going to reduce dramatically the threat of the pollutants that he's producing there. The second indoor air pollutant that I'm going to talk about, I'm going to spend most of the time on this, is lead. Lead is a heavy metal, is extremely toxic. It can be found in lead paint. It can be found in old pipes, but it can also be found in contaminated soil and things like ceramics and toys which have been painted with lead paint. And lead paint was used pretty widespread up until the 70s, where it was started to get phased out. So anything that's from before, like 1973, there's a risk of having lead in it. And lead poisoning, exposure to lead, can lead to serious developmental and neurological issues, impaired mental functions, learning disorders, dramatically lowered IQ, social dysfunction, aggressive behavior. It can lead to bronchitis, kidney damage. It can disrupt your bone and muscle growth. So it's really, really, really bad news, especially for children who are going through stages of physiological but also mental and adolescent development. And it just so happens that lead kind of has a sweet taste to it. So young kids who find a lead paint chip and they put it in their mouth, it tastes good, they're more likely to eat it. But even a small piece of lead paint, chip the size of your pinky nail, can do irreparable damage to the system, the human system. And if you take a look at this map, this is a risk of lead exposure from 2014 to 2018 around the U.S., with purple being high risk of lead exposure and orange being low risk of lead exposure. Gray is not sufficient data. So you can see that there are some patterns around the country with high and low lead exposure. If we zoom in around the area where we're located, this is Greenwich here. You can see that there are some areas of Connecticut and the surrounding New York area that have higher risks. Bridgeport, New Haven, some of these bigger towns, whereas places like Greenwich and Stamford are much lower risk, tend to be more orange as opposed to purple. And if you look at cities like Baltimore and Maryland, you can see there is a lot of dark purple in Baltimore. And if you compare that map to the redlining map, you could see a similarity, right? It's not exactly a perfect overlay. I tried my best, but you can see that the areas that have been redlined or yellow-lined in this case have the areas today that have some of the worst risk for lead pollution or lead poisoning. And that's not a coincidence. Here's a better map. And it shows the red line districts. So red is the worst, green is the best, based on the housing practices of the 1930s. And you can see that the incidence of lead poisoning and lead pollution, which are these red dots, are located far and away more commonly in the red and the yellow sections. There are some in the blue, right? But there's very little in the green. So you can see that, you could probably tell where I'm going with this, there are issues of environmental justice related to lead poisoning in homes in many cities, not just Baltimore. But if you look at Baltimore, you can see, again, each red dot is a lead paint violation. And you look, in this case, the darker purple it is, the more percent black that population tends to be. So you can see there's a very stark pattern between the amount of lead poisoning in the area and the amount or percentage of the population that is black. Whereas if we look at the opposite, in this case, same thing with the red dots representing lead paint violations, but this time the darker blue it is, the more white that population is. And you can see that in areas where white population is very low, that is where all the lead infractions are, the lead paint violations are. There are very few lead paint violations in areas where white people live, right, in Baltimore. This is not coincidence, right? This is almost exclusively due to the redlining practices in the 1930s. And to refresh your memory, this is from this paper here. Redlining is a federally sanctioned unfair lending practice, social policies that denied home loans to even well-qualified black families by treating them as too risky for federally backed mortgages from the Federal Homeowners Loan Corporation, a mortgage refinancing entity. This was started in 1935, and it continued on, I think, through the late 60s, and even after it was legally ended, the impacts of it still echo through many cities today, as you can see in lead paint in Baltimore. Also from this article today, approximately 60% of black Americans live in places that were redlined before 1968. Elevated blood levels in black and other minority children have been observed in these redline segregated cities. One study reported that black children ages 1 to 5 have consistently higher blood levels compared to their white counterparts. And according to another study, 28% of African American households face housing-related lead exposure risk compared with 20% of white families. Right? 8% may not seem a lot. It has definitely gone down over the past couple decades, but there's still a discrepancy there that can have pretty serious impacts. In Baltimore, black children are 1.6 times more likely to test positive for lead poisoning, and because of all the developmental issues that lead poisoning has, these lead levels are actually correlating with crime. If you look at the amount of lead in gasoline, that's the blue line here over time, versus violent crimes, you can see there is a correlation. As the lead in the air started to decrease, violent crimes started to decrease as well. The big threat, though, is that indoor lead pollution through the paint that is often in these old buildings. Thankfully, a lot is being done and a lot has been done. There are a lot of policies in many cities, including Baltimore, prevention programs that strip lead from the homes, repaint the homes, they test, they advocate, they provide legal aid, they do home visits, and they also try to reduce lead in the drinking water, although that's a little bit of a different problem that we'll talk about in the next unit. And there's a lot of optimism in communities like Baltimore, hoping that the lead will decrease substantially, and the EPA has a renovation, repair, and painting program to go through and remove old lead paint and replace it. So there is progress being made. And if you look at the Clean Air Act, which regulates lead in the air via the Air Quality Index, you can see in 1995 to 96, massive drop in the concentration of lead in the air up until present, where it's very, very low. The national standard is very low, and we've just surpassed underneath the national standard for the first time. But we started regulating lead in 1973, and it didn't get fully banned until 1996. So this is a very long battle that could have stopped a lot of preventable deaths even sooner. If you want to learn more about this, I highly recommend this book. I read it in the summer of 2020. It's called A Terrible Thing to Waste. The author, Harriet Washington, talks a lot about lead poisoning and environmental injustice, but she talks about a lot of other forms of pollution as well and how those are not equally experienced by communities of color. The third indoor air pollutant I want to talk about are volatile organic compounds. These have come up a few times now. They can be found in varnishes, building material, furniture, carpeting. A great example is formaldehyde. There are natural sources of VOCs. For example, trees do release formaldehyde, but indoors, again, they build up in high concentrations in closed systems, and they can lead to bronchitis and asthma. Lastly, asbestos. I'm trying to teach as best as I can. You've probably heard about asbestos before. It is a material that was often used because it is fire resistant, so it was used as an insulation to prevent burning. However, exposure to it can lead to cancer, asbestos, and mesothelioma. It needs to be removed safely or left completely undisturbed, or it can be sealed in, but you need to wear protective gear when dealing with asbestos. And you may have heard these commercials. If you or a loved one has been diagnosed with mesothelioma, then you may be entitled to financial compensation. It's kind of funny because it's a bit of a meme, I suppose, but it's also extremely serious. Mesothelioma can do a lot of damage to your lungs, and a lot of people don't know they're being exposed to asbestos until it's too late. There are also some natural indoor air pollutants like mold, dust, and radon. They're not all caused by human interaction or human activities. Mold, I'm sure you've experienced before. People are allergic to mold. I'm allergic to mold. It can trigger asthma attacks. It's pretty gross, but all you have to do is fix the damaged structures, replace them. You can disinfect them. You can dehumidify the area and improve the drainage of the area, and that should get rid of most of the mold. Radon, however, you may probably not have heard of. This is the second leading cause of lung cancer in the United States. It is a radioactive gas that is produced from the radioactive decay of uranium that is found deep in the rocks. The half-life of radon is about 4 days, so it decays pretty quickly, thankfully. But radon is extremely risky because it can leak from underground up into the house. Depending on where you are in the United States, radon potential for leakage is higher than in other places. Red, in this case, is a very high risk of radon. Yellow is very low risk of radon. And radon can rise through the soil, like I said. It can enter the home through cracks in the foundation in the basement, or it can dissolve in groundwater that is then pulled up through a well and then that people drink. And radon is a radioactive material. It can lead to cancer. It is like I said, the #2 cause of lung cancer deaths in the United States. And if you smoke and are exposed to radon, that's 10 times the risk of lung cancer. So it's a pretty substantial risk. You may have the only way I had heard of radon before I started studying environmental science was through The Office. So you may have heard about that. But what we can do is we can use test kits to test for radon. We can seal joints in the walls and floors and install venting systems so that way it doesn't get concentrated indoors. And like Toby says, we should really have the office air quality tested. These are silent killers. You are the silent killer. Go back to the annex, Toby. Boom, roasted. So those are all the different indoor air pollutants, both natural and anthropogenic. And much like we've been talking about throughout this unit, the people who are most vulnerable are the elderly, the young, and those with respiratory illnesses. Why? It's because their immune system is weakened or has not fully developed. They have, in many cases, children have a lower body mass, so a small amount of pollutant can do more damage in a smaller body. And children and elderly tend to spend more time indoors than adults, so they're more at risk for indoor air pollutants. Here's a nice little diagram from your textbook looking at different sources of indoor air pollutants in your home. That's all I've got for you today. Bring your questions to class, and I will see you next time.